Welcome back. This is Mr. Sullivan, otherwise known as just Sully. We are going to be talking about logarithmic functions today. Going to talk about shifting them, graphing them, what it looks like, the intervals that they increase, domain range, a lot of fun stuff, okay? So let's get right into it. Now, first thing we have to remember is that exponential graphs, this is our general form of an exponential graph. This is the equation, this is the graph. This is when b is greater than 0 because it's increasing, and this is when b is between 0 and 1, it's decreasing. So this, let's put in some information here. So when is it increasing? It's increasing when b is greater than 1, and it's decreasing when b is between 0 and 1, right? So 0.02, whatever, 0.5, 1/2, 1/3, things like that. All right, so we want to remember that these two functions are inverses, and that's going to be very important. We'll talk about it in just a minute. So first of all, let's talk about the information from the exponential. The graph, the x-intercept, does it ever cross the x-axis? No. So there is no intercept there. Now, why is that important? Well, remember, when it's the inverse, the x becomes the y. So for our log graph, we're going to have no y-intercept. Interesting. All right. Well, let's talk about the y-intercept. On here we have 0, 1. You'll notice that again in the general form, it's 0, 1 no matter what b is. All right. So that means over here we're going to reverse that. Our x-intercept then becomes 1, 0. All right. So for our log graph, it's going to be 1, 0. Interesting. We can put that dot on the graph. 1, 0 right there. And 1, 0 right there. And as you remember, inverses are always going to be symmetric in the line y equals x, right? All right, let's talk about this next one. The exponential graph at asymptote. All right, so if we have this red curve here, our asymptote is a horizontal line. Horizontal lines are indicated with y equals, and what number is that? In this case, 0. This is the same down here, y equals 0, because this is the general one. We can, of course, shift them up and down as we go. All right? That means, let's look over here. If we were to have an inverse of that, it wouldn't be y equals 0, it would be x equals 0. So maybe we put that on the graph. All right? Let's just put that on the graph right here, down the middle. That's going to be our inverse. Very nice. All right, let's go back to the next one. What is the domain? So our exponential function here, it looks like all real numbers, right? It goes all the way to the left, goes all the way to the right. That's all real numbers. We can write it like that. We can also write negative infinity to positive infinity. Okay? Now we know that the domain of this is going to become the range of our log because they are inverses. So that means our range for logarithms are going to be all real numbers or from negative infinity to positive infinity. That means we have a graph, we're kind of getting it now. It's cut off here, all right? But it's going to go from here all the way to the top. Interesting. All right, range. Let's look at our range. First, let's talk about the exponential. So now 0 is basically the cutoff here, right? So we're going from 0, not including it, so it's just a parenthesis, not a bracket, all the way to positive infinity. Same here. I know it's backwards. It looks, a lot of you want to say positive infinity to 0, but range is from down to up, bottom to top, right? So our lowest bottom would be 0 to positive infinity. All right, that means over here, our domain is going to go from 0 to infinity. So again, if you look at this graph right now, again, our general one is going to be very similar here. It's going to be from 0 to infinity. So everything on this side. That means we kind of just like are not going to use this. Now again, if we were to shift these things, these change, and we'll talk about that in a second. You'll notice that the increasing and decreasing are the same when b is greater than 1 for this general log. So when the base is greater than 1, we're going to have a graph, and you'll see that very similar in just a second. And here it'll be from 0 to 1. Now, let's real quickly just take a look and see what these graphs look like, knowing a couple of things. We have an intercept, we know an asymptote, and things like that. So let's go over here and take a look at Desmos for a second. So again, we talked about this, all right? I'm going to go to b is 2, All right. So b is 2. I know this was a little tricky here. Let me get a better scale. Sorry. All right, so that's 1, 0 right there. Nice, very nice. Now, let's look at, you'll notice it approaches but never crosses our y-axis. That's why there's an asymptote there. And it goes up as it goes up really fast, doesn't it? And then it slows down. Let's compare this. Let's compare this with our exponential. So here's an exponential. Y equals 2 to the x, and its inverse, log base 2 of x. Our points are the same but opposite, right? The x becomes a y. Okay, now check this out. This might be hard to understand. As I go over 1, I increase by 1, but every time that is going to double, right? So now watch this. I go over 1, I go up 2. I go over 1, I go up 4. So my inputs stay the same. My input stays the same. But what happens is my outputs go up much, much, much quicker. So let's write that down. All right. For the x for this, I went over 1, and then I went up 1. The next time, I went over 1, that stayed the same. I went up 2 because it doubled it. Then I went over 1, it doubled it again, and it went up 4. That increases so fast, isn't it? Well, this is going to be the exact opposite. So the first one will stay the same, over 1, up 1. But now, my input is going to go over 2, up 1. My input's going to go over 4, up 1. So here, my inputs are not changing much. They're going up 1. But my outputs are going up very fast. Here, my inputs are going up fast, but my outputs are not going up very fast. Let's see what that looks like. So I go over 1, up 1. Now it takes me 2 to go over for me to go up 1. Then it takes me 1, 2, 3, 4 to go over to go up 1. All right? That's what I'm talking about. So a logarithmic graph kind of flattens out here. All right? Let's see, when would it be decreasing? So let's take this off. So we have this equation. We know that when b is greater than 2, it is increasing. Let's go back. Let's go less than 1. You can see now that it is decreasing. So we can go fill in our table. All right. We can actually kind of put a graph in here. So this one's going to start low, go through this, and kind of flatten out, right? This one is going to start high, go through our intercept, and then kind of flatten out this way. Now, we know that this goes up forever because we know our range is all real numbers. Same thing here. We know this goes down forever. It may take a while. It might be very slow, but we know it goes down forever because our range is all real numbers. All right, let's take a look. So this should be review, but we're going to take the base function of log 2 of x, and we're going to do some transformations. Remember, horizontal and vertical. All right, anything that's a translation, those things are added or subtracted. All right, horizontal is on the inside, so the inside would be like this. Log 2 of x plus 4, that's on the inside. All right, vertical would be on the outside, that'd be like this. Log 2 of x, and then a plus 4. Let's see what the difference is. The difference is on this one, the very first one, I'm going to shift it. The opposite of plus 4 is to the left 4. So now I have a new asymptote. That's the first thing I always shift. My asymptote was at 0. Now it is at x equals negative 4. All right? And I'm going to shift this back, this point, back 4 units as well. All right? And if I wanted to be precise, I know I could go over 1, up 1, over 2, up 1. All right? But we get the idea kind of right there. Correct? That's how that would shift. This shift is up 4. That means I'm taking all my points and going straight up 4. So this point here is at 0, 0 is now going to start at, do a different color, 1, 4, right? This point here would start at 2, 5, and so on. We could go over 4, 1, 2, 3, 4, and up 2, right? But again, we know this time we didn't shift left to right at all, did we? Okay? So if you think about it, let's look at this. What changes here? Does our range change by moving it left or right? No, our range is still all real numbers. Same thing with the vertical, right? It's all real numbers. So our range never changes. Does our domain change? Well, on the vertical, our domain didn't change. Our asymptote was still 0. Did our domain change for the horizontal? Yes. So the horizontal shift to the left did change our domain. All right. So down here, let's talk about that. So horizontal translations, they're going to change that, right? Okay. Let's go to the next one. Horizontal and vertical dilation. So remember, that's multiplying or dividing. All right. So that would look like this. Log of 2x or 2 log of x, right? Remember, this is the opposite. It's basically saying it's like the same as a half of x, right? So I'm going to shrink it horizontally, really. So my graph, if you will, my graph, let's delete these, huh? Let's get rid of these. Does my asymptote change at all? No, my asymptote doesn't change at all, but my values are much, much faster, right? Or quicker, so it's skinnier, a little bit like this. It may not look that different, all right? If I double my values, that means each time when I go over 1, I'm not going to go up 1, I'm going to go over 1, I'm going to go up 2, right? The next time I go over 2 or 1, I don't go over 2. I go over 2 up 1. I don't go over 2 and I go up 2, right? Go over 4 and I go up 2, right? So it's making a little bit bigger there. All right. All right, let's take a look at reflections. Now, does this change the domain? No. Did it change the range? No. All real numbers still, right? And so far, nothing's changed the range. So the horizontal shifts have changed the domain, but not anything has changed the range. All right, let's talk about reflections. So reflections, remember, they have a negative multiplier, right? So let's start with vertical reflections. That would be on the outside. Anything on the outside is vertical. So negative log 2 of x, for example, right? A vertical reflection, it flips it upside down, correct? So all these values are going to be flipped upside down. So let's take a look. So this value is going to stay the same, but instead of going over 1, up 1, I'm going to go over 1, down 1, right? Instead of going then over 2, up 1, I'm going to go over 2, down 1. So now you can see my graph is flipped like that, isn't it? All right. Is my range different? No, my range is not different. The range will never change on these. When you transform these general ones, they'll never change the range. That's important to know. All right, now let's take a look at horizontal. So horizontal would be on the inside. So a negative on the inside would look something like this. So now I'm going to do this here, negative x. All right. That means this value is now a reflection over here. Negative 1, 0. All these are reflected this way, right? Well, I'm looking at the red line, guys. Sorry. So then this value is here, would be here. Then over 2, up 1. So now it's coming in this way. And my asymptote is the same, but my domain is different, isn't it? My domain, it really actually does affect it. So which transformations affect it? Here's another one. The domain is affected with a horizontal reflection. Now this is really important to understand because in a minute I'm going to ask you to sketch these so we can find out the really important information. So when you sketch them, the really important information is going to be in the translations for horizontal and the reflections on the horizontal. All right? The translations of the vertical, the dilations of the vertical, dilations at all don't really change anything, right? And the reflections on the vertical don't really change anything for the range. All right, let's take a look at those. All right, great. Let's take a look. We're going to find the asymptote, the domain, the range, the end behavior, all that fun stuff. Now, right in here, this looks a little wonky, so I'm going to rewrite this. This is natural log. I'm going to take a negative out. A negative of x minus 4. When I take a negative of a positive, it becomes a negative 4. Negative and negative becomes a positive. Plus 2. Why did I do that? Well, that right there is a reflection. Now I know it's a reflection. Now I know that this asymptote is at 4. So what is that? It's going to be x equals 4. Let's start graphing this. As soon as I have my asymptote, I can start graphing it. So these graphs don't have to be great, but they're just there to help you find all the other information. So x equals 4. Let's label that x equals 4. All right, we know what the general graph of these looks like. It's going to come in here, right? And something like this. It's going to go that way. Probably flatten it out a little bit more. It's going to go looking like that. So what is our domain? Our leftmost domain is 4. Our rightmost domain, it goes forever, is infinity. All right? Our range, oh! Sorry, no, guys, we drew the wrong picture, and that's why you have to draw the picture right and look at it, right? So we said that this was a horizontal reflection. That means it's going to come in here and go down like that. Very important. That changes things because now our domain is negative infinity all the way to positive 4. It stops at positive 4. Our range, as we know, is all real numbers. I like to write this, I think, for some reason, negative infinity and positive infinity. But you can write it however you want. All right, end behavior. Remember, for end behavior, we have when x goes to the positives. I prefer you to start with x going to the right. What happens to our y? Well, as x goes to the right, well, check this out. X doesn't go all the way to the right, does it? So we need to erase that. Where does x go to? Well, in this situation, x goes to 4. Now, which side of 4 is it coming from? Is it coming from the right side or the left side? It's coming from the left side. So we need to say, as x approaches 4 from the left, what happens to our y values? Our y values, as I practice at asymptote, they go down to negative infinity, don't they? All right, let's do the next one. As then I go to the right, then I always go to the left. As x goes to negative infinity, f of x goes to, I go to the left. Well, it's slowly increasing the entire time, positive infinity. All right? Now, a lot of people, don't know why I put that, sorry. A lot of people think there's an asymptote here because it's increasing so slowly, but there's no asymptote, just very, very slow. All right, let's do this one. So we have a vertical reflection. That's on the outside, vertical reflection. And did you notice that I never really cared about this number? Didn't even care about it. I mean, this is just a sketch to help me answer the other questions. So, all right, let's sketch it out. First thing first, x minus 2, my asymptote is going to be at x equals 2, because that's what makes that 0. All right? If you're not sure, you could always solve them. X equals 2. But most of you don't like doing that stuff. And that's fine. All right. So we have an asymptote at x equals 2. All right, we can probably graph this right now. We know that it's going to be upside down. So instead of coming in like this, it's going to come in like this. And go down like that. Now, there is a dilation. So this is not a perfect graph. That's okay. Not expecting a perfect graph. Just want the information we can get. All right, so our domain, what's our most left number is 2. What's our most right number? Our biggest x value is infinity. Range is always all real numbers, or from negative infinity to positive infinity, the same thing. If you ever miss this on a test or a master check or a quiz, whatever you're taking, shame on you. Shame. End behavior. Let's take a look. As x goes to the right. So as x goes to the right, goes to infinity. As x goes to infinity, where does my y values go? My y values go to negative infinity. They go slowly, but they still go there. Why do I always do that? All right. Let's take a look as it goes to the left, our end behavior to the left. So as I go to the left, I get stopped by this brick wall. I'm going towards the number 2. Which side of 2 am I coming from? Am I coming from the left or the right? I'm coming from the right, so that's from the positive numbers. So as I'm approaching 2 from the right, my y values go towards positive infinity. They go up rather quickly. All right. So what I want you to try and do, now all of this needs to be done without a calculator. All right. Now the next question I want you to do with a calculator. So what I would do is I would put in my calculator, look at the graph, maybe zoom out, maybe zoom in, maybe use the table of values to see what you can do. I would like you to try your very best to come up with answers for this. All right, ready, set, go. All right, welcome back. So let's see how I got this. So this is my graph and this is what I did. The first graph did not look like this, so I went to my table of values and I saw that the interesting stuff was out here. So I changed my domain on my window from 4 to 8 because it looked like that was where everything was happening, and from -1 to 4 because I didn't need that many values. I needed to zoom in. You could have zoomed in differently, and that's fine. All right. Then I needed to know what was going on. So what I saw was it says there's an error at 6. That is very highly likely that that last error is an asymptote. That's what I'm approaching, right? All these numbers are approaching 5. I just wanted to make sure. So I changed my table value, my increase from my delta, the change from 1x to next, from 1, 6 to 7, to 0.1. So as you can see, from 5 to 5.1, all of a sudden I'm at 1. And then I changed it to 0.01. From 5 to 5.01 was 4. That means you can see that's going closer. It's going up higher and higher and higher and higher. That, in fact, tells me it's an asymptote. All right. So from that, I got a couple things. I got the asymptote was x equals 5. That let me know my domain was from 5 to infinity. My range, of course, was, now this is tricky, but I found the minimum value here using my calculator. Again, I just calculated, calculate minimum. And I calculated it was 0. Now it didn't say 0, it said a really long scientific notation number, but that represents 0. So it goes from 0 to infinity up. My end behavior, as I go to the right forever, I went up forever. I go up very slowly, very slowly. As I go towards 5 from the right side, I also go up forever. That's an interesting thing about this one, all right? This log actually kind of goes up both directions instead of all real numbers. But this is not a basic log, okay? So just so I can show you a couple of things, how did I change that value? My table set, second table set, this here, change in table, that's what I did, all right? Now the other thing I want to show you, because I don't know what happens out here, and this is a wackadoodle of a equation. So I want to go out a long way and see if these values, in fact, keep going up, all right? So I'm going to go back to my table. So now I'm going up by 1,000 every time. I'm looking at my y values, because if they go down, then I have some other stuff going on. But as you can see, pretty confidently I can say these are going to keep going up forever and ever and ever. All right? So that's how you would approach one of these questions with technology. The other ones, you can't use technology. You just got to use your brain and shift them by hand. All right? Best of luck.